Um, my name is Erica, and I'm presenting this information on behalf of the Engineers of Tomorrow team, as well as Lim-Cole from the Durham District School Board. We're really happy to be trialing something here today called Wearing Your Engineering Hat. This is information especially designed for teachers who want to get more comfortable inspiring the future generation of science, technology, engineering, and math professionals, also known as STEM. So this is a really hot topic, and we know that there's a lot of interest in this and maybe some nervousness in this topic as well. So we're going to jump right in with some ideas and hopefully some very practical thoughts and tools and tips and tricks for you. So first of all, here's a bit of a picture of who's going to be speaking with you today. Lim-Cole is she is a physics teacher and kind of a dynamo within the Durham District School Board. She's been working on engineering and STEM type outreach for a very long time now, and her workshops within the Durham District School Board are always very oversubscribed. She does a great job of bringing things to life for teachers. In fact, she's running from one workshop to another as we speak today, so thank you, Lisa, for making the time to present with us. And then down there on the bottom right, that's me. I lead a startup within Engineers Without Borders Canada called Engineers of Tomorrow, and we want to change the future of the engineering profession by talking about it today. And with me on the line today is Becky. She is our operations manager. We both have engineering degrees and have worked in industry and are now taking the time to tackle another challenge on the engineering front on another level with doing the work that we do around talking about engineers. So that's us, and we're excited to share some of our thoughts and some practical tips and strategies for you today. So on this, I guess the agenda, sort of the goals, we want to introduce this concept about an engineering hat, and we'll unpack that a little more when I turn it over to Lisa. Really thinking about how and how you use it and when it works, and we're hoping this will become sort of a go-to resource, something that you can lean on when you're wanting to portray any STEM career, especially engineering, to your students. So we have some tools. We have taken some time to think about this for the last several years through our work on National Engineering Month and a program called Engineer in Residence. We've been really doing our homework on the best ways. What are the evidence-based methods? What does the research say is the best way for us to talk about engineering? And so we want to run through some tools and some ideas that you can leverage based on, based on what we figured out over the last 5 years or so. We're going to condense it down into a few minutes for you today. Then we've got an overview of resources and some recommendations, and then we'll wrap up, and we'd be happy to hear from you throughout the webinar. As you might know, there is a spot here where you can ask questions or comments anytime during the presentation, so feel free to throw your comments in the chat there. Anytime. So with that, I'm going to turn this over to Lisa, our resident expert on teaching and all things STEM outreach, to unpack these next few ideas for you today.
Okay, so thank you for the introduction. So when we talk about the teaching profession, it is one of those professions that creates all other professions, and I think this quote sort of speaks to what teachers are sort of striving to accomplish within our classrooms, to allow our students to discover who they are so that they can think about their role in society and who they would like to become as professionals. And I guess that's a big challenge for teachers, because that could also be very daunting. So what does it mean for a teacher to be able to create an environment that allows opportunity for all of our students pursuing all of those professions? And I think for myself as a teacher, it's a daunting task. So I'm hoping that during our discussion or our little presentation today, that we can focus and think about the role that teachers play in helping to help our students envision themselves as engineers and what that might look like. So first to start, so the next slide there. Let's talk a little bit about wearing these hats. So if it's true that teachers inspire students to pursue different kinds of professions, then It would mean that a teacher would need to pretend that we are athletes at times when you're teaching physical education and health, that we're scientists, whether it's biologists, chemists, or physicists. What does it mean to be a police officer, an architect? So all of these professions emerge out of the students that we teach. And yet when we teach our students to help them envision themselves in these professions, we need to think about how do we put on those many hats. I think of teachers as actors. We play out parts. I mean, we teach language, arts in elementary school, English in high school, and yet we haven't actually written a novel. Or we teach science, but we haven't necessarily worked as scientists. And what does that mean to be a scientist if you look at, even science, right? Are you chemist, biologist, environmentalist, all of these professions. And in particular, if we focus on engineering, which is the topic for today, most teachers are not engineers. And even if you did have an engineering degree, it makes you think about what kind of engineer were you if you had an engineering degree, and how are you representing that profession within your professional practice or your teaching. If you also look at teachers generally, we have university degrees, but there's a whole realm of STEM professions and STEM careers that emerge out of college programs. So we ourselves have not experienced all of the ways in which our students explore education, obtain their training, and yet we are to put on those hats to help our students envision themselves in those roles. Next slide. So we wear lots of hats as teachers. We tend to think about how do we influence our students. How do we message in a way that will help our students envision themselves in those roles, but also not misrepresent what those professions might want. And I think this is why in my collaboration with Erica Lee, as well as Engineers Without Borders and Engineers of Tomorrow, and all of the engineering faculties in Ontario, I have started to think a lot more about what is the key messaging pieces that we need to infuse inside of what we do as teachers to ensure that we are making it accessible for a diverse group of students. So there's a few questions listed there, and I'm thinking that if the participants might want to think about these questions. What are some of the experiences you've had with STEM that might be influencing your opinions on the STEM fields? How are these experiences translated when you talk about STEM? And what are some stigmas associated with STEM? I think these are questions that sort of speaks to the current narrative of engineering or STEM that might exist, but also will help reshape the new message that we might want to relay. Wondering if anyone has any comments to add to that.
Carry on, Lisa, you're doing awesome.
Okay, so in looking at the engineering profession in particular, so the questions that I had as in my school board, we actually do have a STEM plan implemented, and the E part of STEM was a little bit of a mystery. It's a little bit of a circle, like question mark. And myself being a physics teacher, although I knew that most of my students typically went into engineering after a grade 12 U physics course. So it's a popular profession in the students that end up taking physics. However, I didn't really understand what engineering is. So my questions were, what do they do? What motivates them? What strengths and skills do they what should they have? What do they accomplish? And where and how they work? These are all mysteries. These are things sort of that a teacher is not fully aware of, and hence our students, although they may apply to the engineering, program, let's say out of a grade 12 high school degree, I'm not sure that they really know what they're getting themselves into. So when thinking about our STEM plan for our board, I really felt that E needed to be addressed. and what is that E? And in order for me to sort of think through what that E might mean in our plan, I felt that a lot of discussion around how do we want that E to be represented needed to happen. And then how do we help our teachers sort of wear that engineering hat? When we think about teachers, teachers are often role models for many of our students, and if a teacher is not armed with that hat for engineering and an ability to represent it authentically in a way that speaks to our students, then I think that very quickly many of our students may disengage or may not be opened to or experience enough to know that that they can relate to that profession or that way of thinking. So those were my bigger questions in terms of how do we support our teachers to be able to speak to engineering even though they are not engineers, and what is the message we want to relay. The next slide. So on that note, I'm going to pass it off to Erica, who's going to talk a little bit about the engineering identity.
For sure. So thank you, Lisa, for that. I think that the thing that we wanted to say as we were speaking to teachers, and Lisa especially, and understanding a little bit more about the challenge that is in front of teachers as they try and represent engineering and the potential career path of engineer to their students in a very authentic way, and sort of scratching their heads a little bit and not knowing exactly how to do that. I think we want to really validate that for any teachers out there who are feeling a little bit of that feeling a little mystified, because we as engineers sometimes think that as well. Even myself, I graduated with an engineering degree. I went and worked in industry. I got my PN designation. You know, I'm legally allowed to call myself an engineer. But the problem is that there are so many different fields, and there are so many different ways to think about the engineering profession. And this is a slide we're going to get into later. Like, it used to be really just about safety, but now it's even more. You see so many different roles and types of engineers. There are sales engineers, and there are design engineers, and there are manufacturing engineers, and there are so many different types of engineers, costing engineers, human factors engineers. The engineering identity is evolving, and engineering, we hope, is becoming more prominent and more well known. So part of what makes engineering tricky to talk about is the fact that it is, like technology, like society, it is evolving. There are so many narratives, and it's a living, breathing, human-built organism. So that it is, that just makes it kind of challenging to talk about in absolute terms at times. Another thing that makes it difficult is that the engineering licensing body, and in Ontario that's the Professional Engineers of Ontario, that give out the licenses, and then they make sure everyone is adhering to certain standards of professional practice. And this is very important because we need to make sure that people that are doing things, especially big structural things like certifying how a municipal water system runs, bridges are an obvious example. You don't want the bridges to fall down. Anyone that's providing engineering services to the public especially has that duty to do their job properly, and so the license, the practice of professional engineering needs to be controlled and regulated. And so they're very fixed on PEO, Professional Engineers Ontario, is very, very, I would say, very strict about the term engineer. You can only have it if you've passed through their certification and licensing process. Otherwise, you're not allowed to even use that word. So the fact that PEng and engineer are trademarked and licensed sometimes also makes it hard to talk about, because what about the people who aren't licensed? What about the people who studied engineering and still consider themselves engineers, and maybe are doing some things that are relatively close to engineering but not exactly engineering? There's a bit of a fuzzy line there, and it's not always easy to establish. Another thing that makes it hard is that that fuzzy line between practicing engineering and not practicing engineering. Again, there's something called the Professional Engineers Act, a very important act for our profession in order to make sure we're doing our jobs properly. That said, a part of that definition of practicing engineering is that it requires the application of engineering principles. So here we go around again. What are engineering principles? I mean, it's almost like an onion you have to keep peeling the layers off of. So all of this to tell you that there are internal factors within the profession of engineering that sometimes even those of us that spend a lot of time thinking about engineering and even a long time working in the profession of engineering is we're not necessarily able to represent the entire engineering experience accurately either. So this is basically just to say this is a big challenge, and we have got some tools that we would like to propose to you so that maybe you can be up for the challenge of representing engineering authentically, even though it is just a tough thing to do, and you shouldn't feel bad if you're feeling a little daunted by that prospect. So we've got a little bit of an interactive activity here we want to do. Now, if we were doing this in person, we would make everybody stand up and form a line according to where on the scale of 1 to 5 they came in on each of these questions. What we're going to do here, because we're on a webinar, is we'll get you to put your answer in the chat box. So everyone that's on the line, please humor me, play along here. We just want to get a sense of where people that are on the line with us now are feeling as far as this whole question of representing engineering or wearing that engineering hat. So first question we're going to try on here is, I understand the work that engineers do and would feel comfortable describing it. So 1 is strongly disagree, 5 is strongly agree, or anywhere in between that you might fall. If you could pop your answer in the chat box, please. Thank you. I see a 4. I see 4. Okay, pretty good considering the obstacles we just outlined to understanding what engineers do. I would put myself at maybe a 3, maybe a 4. Yeah, I think it's something I'm getting a handle on, but it is tough to be that completely confident given some of the factors we just unpacked. How about women and minorities are well represented in engineering? Where would you say you are on the scale of 1, strongly disagree, to 5, strongly agree? Okay, so we've got a 2 for this one, a 1. Oh, thank you, Sandra. That was a 2 for the last one. 1 for strongly disagree. Yes, I think I would probably be in that bucket myself. I would give a 2 to that question to say, because I think that we're making some major strides. One of the finalists for the Canadian banknote, the woman on the Canadian banknote that just got announced this morning, was Elsie McGill, who was one of the first aeronautical female engineers. Very important historical figure, very inspiring woman that worked during the Second World War. Look her up, Elsie McGill, if you haven't got a chance. She didn't end up being chosen, but she's a fantastic role model and an example of an accomplished woman in an engineering field. When we talk about minorities, something just to note here is that we are talking about gender diversity, we're talking about ethnic and racial diversity, but we're also talking about personality. We want to have extroverts as well as the, maybe stereotypical introverts that we might associate with something like engineering. We want to have people that are big picture thinkers and people who really thrive on the details. We want to have people that are really concerned with the well-being of a community versus the people that are maybe a little more pragmatic, focused on the bottom line. So these are just some examples of the different types of diversity. When we say minorities, we mean anything that doesn't represent kind of the status quo of the profession, because we know that that diversity is something that's so important for the future of the engineering profession. Okay, great. So we agree we've got a long way to go on the diversity and inclusion. So what about most adults understanding what engineering is? We're trying to get at sort of where do we think as a sort of a public education, public awareness question. How are we doing on that? So I see a 2. I see a 2. Okay, yeah. So I would concur with that. I don't think many adults understand what engineering is, unless you happen to be related to someone, or in case you know an engineer in your social circles, then maybe they've given you a little bit of a taste of what what they do in their jobs. That might give you a bit of a sense. Something that we think is really important is that engineering students graduate and sort of grow up into the profession and learn to feel as though they are responsible for helping spread good awareness of what engineers do and what engineers are. So, for example, things like, when we're covering the federal budget, or when we're looking at a question like infrastructure, or what to do about, the Gardiner Expressway that runs right along downtown Toronto. We want engineers to be part of that dialogue and to be seen for the subject matter experts that they are. We don't necessarily just want to see politicians being interviewed, for example, or going to, say, someone who's maybe a little more media savvy but isn't as aware of the technical ins and outs of the issue. So we think that public awareness of engineering is really important. Okay, bringing it back to your students and a message you might give to them. Let's see, true or false? Do you agree or disagree? If you're good at math and science, you'd probably be good at engineering. How do we feel about that particular sentence? Okay, I see a 3. I see a false. Okay, cool. So like maybe a 1 or a 2. This is a tricky one. 2, yeah, I think I would also be middle of the road, because math and science, practically speaking, those are the prerequisites that these students are going to need coming out of high school into the engineering program. However, even if they don't have super high marks, or they can still be excellent engineers. They can go on, they can contribute. Myself, I didn't have the most amazing marks, but I make up for that in many other ways, and bringing that to the table, I was actually able to have pretty good success as a manufacturing engineer and a Six Sigma problem-solving expert in the factory where I worked. And I maybe wouldn't necessarily have had that if I had just had my nose in the books all the time getting 95s. So an engineer, really, I guess what we want to say here is that it needs to be also a well-rounded person, that this is a person who can communicate, this is a person who can work in a team, who can think big picture sometimes, who can get a sort of a theoretical to practical kind of a conversation going. Those things are all very important. So math and science are important to get through the education, but as far as the day-to-day practice of graduated engineers in the field, it's not just about math and science. There are many other things as well. So this is one of those partially true sentences, we think. So all of that to say, we know where we're at and where we need to go. Let's talk a little bit more practically about how we're going to get you that engineering hat. And Lisa, I'll turn this back over to you.
Yeah. So I've been thinking a lot about how do we arm teachers in our classrooms with tangible tools to support STEM skills. So I say STEM skills because I think it's not solely isolated to engineering, but generally speaking, all of the fields in science, technology, engineering, and mathematics. What is it that we're looking for? And when we think about that process for learning, I mean, we're at an age now where information is pretty much unlimited, and with the internet. So how we teach and how we engage our students to learn has been forced to change over the course of the last, I'd say, even 10 years. And it's a slow process in many ways, because I think we're still adapting and we're still trying to innovate within education. But there is an urgency to think about how we're going to address STEM in our classrooms. And so what are the tangible tools? I think part of it is methodology and pedagogy of teaching itself. I think we need to move away from thinking about the content as being the sole provider of skills or requirements for learning for our students, because having that content piece is, over the long term, not the piece that will make that exemplary engineer. The content is, if you have to look something up, we can now. And very rarely are we under a time pressure where we need to be able to regurgitate content in order to do our problem solving. However, there is a balance between developing an understanding of the content in terms of easy access to facts and the efficiency of knowing those facts for an intended purpose. And an example of that is you think about how efficient would it be to solve a problem if you had to look up every word in a paragraph before you can actually solve the problem. So there is a delicate balance between that content piece and then the skills development piece. But when I think about how do we support our teachers through the development of wearing that engineering hat, I think it is the problem-solving piece. I think it is, we do need to provide good examples of activities, hands-on experiences that messages what an engineer might do. I think it's about explicitly teaching or explicitly modeling the engineering design process within the context of the classroom that's still anchored to that content. So in Ontario education or in education generally anywhere, there is a curriculum that we do need to adhere to, but how do we infuse that engineering process inside of the learning of that curriculum piece? And so when I work with teachers, I do think about moments of interrupting that curriculum to explore how the engineering design process could be used to build better understanding of the content that the students are exploring. Inquiry-based learning is something that happens in classrooms or is encouraged to happen in classrooms. But when I think about the inquiry process for learning, it typically is represented to start with a question. But to ask our students to develop a good question to inquire about often requires an experience or an inspiration or a moment of wonder. And I think engineering has an opportunity to play that part. So if you have students exploring through an engineering design process, they might develop some really rich questions, which will then inform an inquiry, where then that inquiry will emerge into another engineering design opportunity. So I think in terms of tools for teachers to become comfortable enough to wear that engineering hat, I think we do need to think about how do you interrupt the everyday inside of your classroom to provide an opportunity for students to explore that engineering design process. I think the other important thing for teachers is to see that the engineering design process is essentially that. It's a design process. And when we say design, I think it becomes a little bit more welcoming. So I think about how we message that with our students. I see, as a physics teacher, I see that in the elementary school curriculum, I would say that it is very heavy in physics concepts inside of the Ontario elementary school curriculum. And yet the word physics is never mentioned in the elementary curriculum. And I think engineering is one of those things as well. If you look at explicitly within the Ontario curriculum, at some of the activities or the suggested lessons or topics, there are many opportunities where engineering could potentially happen, and yet the word engineer or engineering doesn't actually exist in that curriculum document. So I think being comfortable with the word engineering enough to recognize that it actually is embedded and infused inside of our curriculum gives us permission to explore that. I also think that in looking at the messaging piece, if we engage in engineering design activities with inside of our classrooms in partnership with our students, and we co-learn what it means to be an engineer together, I think that sets an example for why it's important to engage in that engineering design process. I think oftentimes we're afraid as teachers to sort of let our sense of control dissipate, and that we actually allow ourselves to be a part of that learning process that sense that we are not experts in the room, but we are co-learners, is sometimes a shift in our own teaching mindset. So I think when I look at the messaging of that word engineer or engineering, we often look at it as a special word that others do. And yet, I think the many things that happens in classrooms, we are actually engineers. So when I look at the word engineering, we typically stereotype it to mean things like bridge building, or design a device that when you drop an egg, the egg doesn't break, and very mechanical. And yet, when teachers are problem solving how they're going to design a lesson to deliver for an intended purpose, the whole notion of planning and trying it out in your classroom and then reflecting on it and revising it, I would argue is a form of engineering. It's an engineering of a concept or an idea. And if we start thinking about ourselves in some of the problem solving that we do as teachers and include ourselves in saying that process of solving those problems in our day-to-day work as professional teachers could also represent what engineers might do in the context of engineering a solution to a difficult problem, then I think it becomes a little easier to wear that engineering hat. And that engineering isn't about only tangible physical things that we solve problems to, but I think about a profession like systems engineering, where you're looking at efficiencies of how to implement a change inside of a system. So I often joke a little bit about how could you imagine a systems engineer redesigning efficiency for the educational system in Ontario. So it's not always about the physical bridge-like object, but it could be about re-engineering or engineering an idea. And if we start engaging in those conversations with our students, I think we would open up the dialogue and the possibilities for potentially a more diverse group of future engineers.
Thank you, Lisa, so much for sharing that perspective. And I could not agree more with what you said about modeling that openness and curiosity as a way to explain, or a way to sort of model engineering. I think that's perfectly said, because engineers are, if we can say anything about such a diverse group of people as engineers are, with all the different fields and disciplines and industries that they work in, I think we can say that they're curious, and we can say that they want to know how things work, and they keep asking why, and they keep digging, and they're interested in finding ways to do things better. And so if you're, part of donning that engineering hat in the classroom can be the courage to say, I don't know, but let's find out, and using that curiosity to propel you forward. That's definitely very engineering-like. So love that point. I think that's fantastic. So we're now into the section where we give you some tools, and I think the first one we want to talk about is messaging. Now, when we talk to engineers about messaging and encouraging them to send a certain message about engineering, we have a lot of volunteers that we work with, and they're engineering students and engineers, and believe it or not, it took us a long time to convince them that messaging was a thing and that it was a good idea. I think teachers maybe understand that a little more, since part of education is about delivering a message, and they do that every day when they get up in front of their students. But we just want to give you a little bit of an idea of the way that we think about messaging and really why it's important. So you can see here we've got this little S bubble on the left-hand side that says this represents the number of students. Out of all the students who could go into engineering, these are the ones that will choose engineering without any intervention. They probably have a family member who's in engineering and will encourage them. These are the kids that are showing up to the robot building events, and they're excelling at the bridge building, and they're just sort of sold on the way that engineering is being talked about now. So they're going to go into the engineering profession, and then they are, at some point, we hope, going to grow up and go volunteer in a classroom or go talk to their kids or their nieces and nephews or their kids' hockey team about engineering, and they're going to say something about engineering that kind of reflects their experience and the fact, like, yeah, I was, I was a pretty introverted kid and I liked math and science, and sort of reinforce that kind of maybe narrow or sort of default understanding of the profession. Whereas if we go to the next slide, um, what if we were to take a whole bunch of different types of people and say, like, here are the kids that are going to choose engineering no matter what. We've still got them. What about appealing to the kids that want to change the world? And what about appealing to the kids with the strongest leadership skills? And what about appealing to the kids with the biggest and boldest and craziest ideas? What if we told them that engineering is a place for them because of the way they are, not despite the way they are, but because of the way they are, and saying, you know what, engineering is a place where we need lots of different thinkers, we need that creativity, we need that person who can have a vision and go after it, we need those people who care genuinely about the state of humanity and society, and that's a great place for you to be in engineering. We're going to get these people that grow up, and I think I'll speak for myself. I think I probably represent one of these sort of other bubbles. My parents aren't engineers. I don't fit the mold of that kind of introverted, just cares about the numbers, sort of a stereotype, sort of a mold for an engineer. And so now I'm growing up and I'm holding up a different type of an image of what an engineer can be. I'm modeling a different type of a way to be an engineer. And so over time you see these arrows coming back from the engineering profession talking to the engineers of tomorrow that are the kids of today and sending out all these different messages, all of these different little personalized, almost like a bat signal saying, like, come join us, engineering is great, it's fun, it's a good place for people like you, even if you don't fit the mold, even if you don't fit the stereotype. And that's how we're going to drive this diversity that's going to come into the profession, and it's going to change the face of the profession over time. That's really our long-term vision for what this could be, as far as a way to shift the profession and an opportunity to change. So that's kind of a little bit on why we think messaging is important and what can happen over time, especially when we partner with teachers like yourselves who get the bigger picture of what we're trying to accomplish. You don't need to have gone through and gotten an engineering degree the way we did in order to relay this message and to be part of this change that we're creating. So that is just a little bit about how we see the change working and how you can be part of it. And now Lisa's going to take us through just a little bit more specifics around those messages around engineering.
Okay. So currently, the message around engineering is that you need to be good at math and science. And if you are good at math and science, then you should study engineering. That engineering is equivalent to scientific aptitude. Engineering is equivalent to building stuff, so the physical. And that engineering, well, maybe a misconception is that drives trains, the old definition of the engineer. So if this is our current message, then you could imagine that we're talking about a very small fraction of the bigger whole population. And for years, this has been sort of the understanding. And I would say that currently we still have elements of that. And I'm not suggesting that we have perfect solutions to this because, I mean, let's be honest, university engineering programs are high stakes, marks driven. There are prerequisites, and the prerequisites does include grade 12 physics in Ontario. So grade 12 university physics, and then we probably all have personal recollections of what that experience looked like, and or the stereotypes behind what students takes grade 12 university physics, or back in our days the OAC physics, right? So when I think about our current message, does it actually really align with what the engineering profession needs or wants? And what does our society need and want? And so when we look at what we would like our message to be, so the next slide, we need to consider number one, why this needs to even happen, and then if it is something that needs to happen, then what are the things that we want to message? And so when I think about our society, and maybe just Canadian society, but even more broadly, our global society, we're probably faced with some of the most difficult problems that exists in our history. Like we have climate change, for example. And when we think about the complexity of the problems that exist, and we have a group of people who have a particular skill set because we have narrowed down the kinds of skills we have put importance on to streamline and a particular profession to have only certain characteristics, then how are we asking this group of people to come up with creative solutions to very complex problems? And when I think about that piece, I have to question, what are the characteristics we want our engineering profession to be able to have within the whole collective all the tools that they might need to tackle very difficult problems with a lot of variables. So, and I can say that about science programs as well. So I look at physics. I would say physics has the same issues that the engineering profession does. So when we look at what we actually want, there are some four criteria there that we're looking at. We need diversity in thinkers to tackle some of the toughest problems that exist globally. We need engineers who are thinking about, sure, today, yesterday, but also shaping innovative solutions, looking into the future. So we need people who are actually visionary in tackling maybe anticipating some of the future problems that we might actually encounter. We need people who are creative and imaginative, thinks outside the box, because we are dealing with very complex problems, and maybe the problem requires a different way of looking and approaching the problem. We need people who are connected to society, and I think sometimes when we think about the engineering profession, we think of it as a very logical thinking, problem solving, very mechanical, mathematical kinds of people, but the engineering profession is always tied to a societal problem or a societal need, a want to improve society. And so this idea that engineering is a helpful profession really needs to be at the forefront of the messaging of the profession. We think of healthcare as being a helpful profession. You ask many students what they want to do, and they'll claim that they want to be helpful. They want to do something that makes change, and they will go to professions like medicine or veterinary sciences because they immediately see those professions as being helpful. But I think the engineering profession is truly a helpful profession, but the messaging of the profession has prevented that perspective from actually emerging. Next slide. So going from that, we think about the stories that connects the engineering profession to the people, the actors of that role. And because the profession itself is a bit of a mystery, and it seems that many engineers become engineers because they have known somebody who is an engineer, that personal connection piece is really critical in reshaping the engineering profession. So real-life examples with a description of not only what they do, but who they are, what are their interests. And I think that makes our students far more connected to the profession, and I think that's really important. The next slide. So there is a website, nemontario.ca, that has created a data bank of lots of profiles of different engineers. And I think this is one of the first steps in sort of providing that personal connection to, could I be an engineer? What do they do? And the scope of all the kinds of engineering professions that exist, I think is also important. I know that, I've had discussions with students where they're often surprised that an engineer works at a hospital. They thought that only doctors and nurses work there. The reality is that hospital requires engineers, technicians. They require researchers in the fields of medical physics. to actually do all the work that doctors and nurses do in the building. So you can have a role in healthcare through engineering as well. And I would say that I would make an argument that that exists everywhere. An engineer exists in movie making. And so you could have interesting blends between professions or between skills. And I don't think that that is necessarily communicated to our students and our teachers. And arming you with those stories, I think, will help you wear that engineering hat as an educator. The other thing, too, that I've included here on the next slide is the impact that stories have on representing engineering or the engineering mindset. And I think we can start that very early on when we introduce our students to language, to reading, to thinking about stories. And so in partnership with another teacher here in my board, we started to collect these storybooks that helps to sort of engage students at a younger age at the idea of what it means to engineer or that engineering mindset through story. So there's lots of great books. The Most Magnificent Thing is fabulous. The Fantastic Elastic Brain. There's a whole series of books that I've listed in this slide, which you can't read, but we would be more than happy to share this list with you. And more recently, I keep adding more stories as I develop workshops. And what I encourage you to think about is how do you not only introduce engineering through the storybook, from reading the book from beginning to end, but thinking about interrupting the story at a moment where you would then explore an activity through the engineering design process to help our students develop an experience that would inform their thinking around what the story actually means, to then help them infer what the story where the story might go. So I know in language we talk about, making inferences about the story. And I think sometimes when we deal with text that involves engineering, it's difficult for students to potentially infer when they have not connected with someone who is an engineer or would have engaged in an engineering design activity. So I challenge teachers to think about where could I interrupt this story to then have students experience something to help them infer something about the story that will then help them predict where the story might go and then develop a richer understanding of what the engineering design process might be. So there's a whole list of storybooks that I've started to collect as I develop workshops for teachers. Now, when we also design engineering style activities, I think it's also important to think about that social context. How does it build into the community? For example, in this slide, you'll see a picture of a popsicle bridge project. And lots of these activities are happening in classrooms, and it speaks to many because it's fun, it's engaging in the sense that you're building something with materials. You get immediate feedback because you're testing it by adding load. You can modify your design depending on purpose. So here there's some rods that are put along on the table so that the bridge is asked to sit on a potentially unstable, ground similar to what it might look like in an actual environment. But the extension to that might be a piece where you connect it to a particular community. So thinking about how your own city might need a bridge and how it may need to be situated and how it might need to be designed to meet the needs of that community might be a way to engage that bridge building activity to a different audience and making that social connection. I think about how all of the activities that we do that are stereotypically engineering should be remessaged in a way that engages a different kind of student who might find more importance on that social context than maybe the physical building of the bridge, or how that person who engages in the physical building of the bridge, how they might need to develop an understanding and appreciation for how that build impacts society. So what we're doing is providing a particular message for our students that actually incorporates and infuses the overarching themes of what we would like the engineering profession to represent in our society. So when we look at making sure that our message to our students clearly articulates what we intend to represent our engineering profession to include, that math and science, you do need it, but it's not the only thing you need. You don't have to be super smart to be an engineer, although the requirements for getting into the some of our engineering programs are quite steep. But there are other ways of getting there. I've had students in the past enter first-year programs in science and then switching over into engineering. There are also many people who go into science and then pick up graduate work in engineering. So I think it's really important to sit down and plan your routes and career pathways to still engage in the possibility of engineering and keeping options open. And there isn't just one clear path to get there. Engineers don't sit and calculate things all day. I think that's a misconception. That engineers are intelligence, and I would say that it's not just about engineering, but generally speaking, is not static. I think what's more important is that we engage in lifelong learning and our ability to adapt and change and develop curiosity, as Erica mentioned earlier. And we need all kinds of people in the engineering profession. As I mentioned earlier, complex problems require a diverse group of people to tackle them, and I think that by narrowing the kinds of skills in our students, thinking that only mathematical, scientific types should be included is a myth. The next slide, please. So the engineering profession requires many skills. You need imagination, communication, a vision, a desire to help people, to engage in conversations with many people. So I think science and math is not the only thing you need. In terms of high marks, it is competitive. I can't say that that's not true. However, I think that the students that excel in engineering programs are not necessarily the students that only know how to do those calculations or know a whole bunch of facts, but they are very creative and innovative in terms of how they use that knowledge, how they apply that knowledge, and how they can collaborate with each other to actually do the work that they're assigned to do. I think the engineering profession is definitely a team sport. Most jobs work in teams. Very rarely would you work alone, and you have to be very good at communicating. So in terms of intelligence, I think the idea of growth mindset is really important, and I would say that that's true for any profession. The ability for us to think about how we approach our own learning, being reflective about our own practice as teachers, for example, is just as important as it is for us as it is for engineers. I think generally speaking, our students need to become very flexible in how they approach learning, and our role as teachers to develop that skill in adapting and constantly learning is really important. Engineers require a wide range of skills. So as a classroom teacher, I think it's important to think about, if it's not about the content of science and just math, but it's application of it and the skills required to do it. So I can think about communication, collaboration, critical thinking, creativity, the 4 C's. I think that it's important to infuse that inside of our classrooms and providing students an opportunity to learn in that way. to make sure that they're ready for potentially an engineering profession. So Erica is going to talk a little bit about the truth about engineering next.
That's great, Lisa. Thank you so much. So I think as I spoke earlier, it really isn't just about the technology and just making it work. I think sometimes people feel like engineering and technology are the same thing. Science sort of creates the insights. Technology is the end product that all of us use every day. I know we're all glued to our phones and our computers and we love our technology. And engineering is kind of the bridge in between that helps transfer or translate one into the other. And they are all interrelated and interconnected. There's overlap for sure, but each is different and it's distinct in and of itself. So as I hope we have unpacked for you today, this is sort of summing up something that we really want you to take away from today is that engineering is fundamentally not just about technology. It's about serving our world and making it better for people. We do need that technology, that technical knowledge, and those sort of pure skills of the math and science. Those are sort of like the raw tools. But then there's the ability to apply them and to connect them to real-world problems, to interact with people, to make sense of what's going on in the real world, to reflect and be curious and be resilient, as Lisa was talking about earlier. Those are also essential pieces of the profession. So the world is really interconnected and complex. We're not just building sort of one-cylinder engines anymore. We're talking about going to Mars, and we're building these glass roofs for houses that are going to house solar panels. Like, there are really complex and interesting things going on in the world right now, and we need people that are able to think at that level. So what that means is we need lots of diversity, lots of those different arrows feeding into the profession, with different types of kids bringing different types of strengths and interests into the engineering profession of tomorrow. And that diversity is a strength, and we need everyone's ideas. So there's a redefinition that's going on that's saying, that inner circle that you see on the diagram on the right there, that it is about technology, it is also about safety. Time was that if the technology worked and it was safe, that pretty much meant that you were knocking it out of the park. Recently, we've started to look at how we're using our resources and what happens at the end of the life cycle of a certain item. Plastic water bottles are something that come to mind. It's not just enough to make a technology that works and doesn't hurt people. It also has to be sustainable and has to not leave an irreversible footprint on our planet and on our resources and on our economy. And part of the shift that we're seeing even now, and part of what we feel we're helping to create through our outreach work and through partnerships with teachers like yourselves, is to help people see that engineering really has always been about global social implications as well. So what happens when Canadian mining companies go overseas, for example, and start to make things happen, start to put down operations in these overseas places? What are they doing to local economies? What are they doing to the local water? What are they doing to the population and the social fabric of the places there? It's not just about making it work or about making it work safely or even sustainably, but it's also about, does this contribute to a world that works for everyone? Is this part of what we want to see in the world? And so in that sense, it's really exciting to join up with teachers and realize that you're also invested in shaping the future and in seeing a world that works for everyone and in creating change through the work that you do every day. And so we see that we have this in common, and this is a great opportunity for us to partner together to get to that world that we're wanting to work towards.
So in conclusion, I think just a recap of what we were exploring today is this quote from Nelson Mandela: "Education is the most powerful weapon which you can use to change the world," I think speaks very loudly to what educators do. I think when we started this discussion around how teachers are the creators of other professions, and teachers also have a role to play in creating students that are engaged in wanting to change the world and to make the world a better place. this quote actually speaks to me personally, because I think about, you know, how much I have gained from the education that I have received in order to do some of the things that I do, and how I support teachers within my school board to provide opportunities for a larger audience of students. So I often think about the power in that, and how we have an opportunity to really collectively work together in partnership and collaboration to provide more opportunities for many of our students, and shift the dialogue that is happening within our classrooms to help our students re-envision their own futures, and think about how they too can become engineers and join that profession. So as a quick recap of some of our discussions today, so the key takeaways is thinking about, in order to wear the engineering hat in your role as a teacher, I think we need to think very critically about what is the message we give, and how do we wish to give that message. The idea of storytelling and how story can play a role, how we connect with people who are engineers as people and not just as a profession of outcomes, but rather as individuals. How the message and that activity, how it makes an impact and how it connects to society, I think is really important. And really thinking critically about what is the truth about engineering, what is our hope for the engineering profession in Canada. So thank you for listening.
Thanks, Lisa. So I think just to wrap up, we'd like to invite you to meet with us. More practical and tangible ways that you can partner with us are to invite an engineer in residence, that's an engineering volunteer, to come into your classroom to help kind of be a flesh and blood example of the future that some of your students might be interested in. We are now taking applications for September 2017. So if you're interested, you can look for more information on eir.ca. More immediately, though, National Engineering Month is coming up. As you might know, that's celebrated every March. And we've got lots of great resources for you. Keep watching nemontario.ca for articles, profiles, lots of events coming up. There are going to be, we hope, over 300 events coming up across Ontario. So that would be, that would be a great opportunity for you to reach out and gain some valuable tools and messages and examples to pass on to your students. So I think, Becky, unless you have anything else to add, I'm just going to say that we would love to connect with you on social media. Really grateful for you taking the time to check out our content today. As I mentioned, this engineering hat concept is a little bit new for us, and we're experimenting as we go. We're kind of designing and engineering this whole presentation, and we're really interested to hear, like, what works for you about this presentation, what resonates, what surprised you, what made you excited, maybe what feels still a little bit scary or intimidating, or anything you didn't agree with. We'd love to hear all of that feedback so that we can take it forward and make it into the next iteration that we'll continue to share with teachers. So Becky, do you have any closing thoughts before I wrap up the webinar?
No, nothing from me. Thanks. I think just again to say thank you to Lisa, and just to reiterate what Erica was asking, again, any feedback is welcome.
Fantastic. And Lisa, any last words from you?
No, thanks for having me. Thanks for joining us.
Well, thank you, Lisa, for all the hard work that you've done, and thank you for making time in your very busy schedule to do this with us. And kudos to Becky, who did the majority of the legwork to pull all these slides together. We're really looking forward to hearing what you think, and to partnering with you further on shaping the future of the engineering profession and getting you into that engineering hat.